So this video is for those of you guys that haven't taken physics and you just don't have a lot of experience with this. And so it makes it a little bit hard at first. So it's just a reference for you to kind of get an idea of what's going on with a position graph. Okay, so you're always going to look that this is x and this is time. Okay, so it's a little bit weird because our brain is not used to seeing x going in this direction. Our brain wants to see it going this way. Okay, so I'm gonna show you a different picture of this. So what you're thinking about is a particle moving back and forth. Okay, so when we start particle motion, we start with a very simplistic idea of just a little particle randomly moving back and forth. It could be up and down. And it won't be until later that we can talk about it sort of moving into two ways. Okay, so I want you to think about this is the position, okay, on the x-axis of the particle at a given time. So if we're in the position function, you want to think about, okay, if s of t is position, velocity is going to be the derivative or the slope of position. Okay, so this is telling me right here that it's going up, and the velocity, because this has positive slope, the velocity is positive. So I know that the velocity is positive. Okay, right here, we're at 0, so velocity is 0. Here, the slope is negative, so I know that velocity is less than 0. Okay, right here, velocity is 0. Okay, so here and here, velocity is still positive on both of these. One is going a little bit faster than the other. Okay, so there's velocity greater than 0. Okay, and here velocity stopped. Okay, so this is telling us kind of not only where the object is, but how fast it's going. So that's something brand new. Okay, so remember that what we said, that if velocity is positive, okay, maybe I'll put here, that if velocity is positive, then the object is moving to the right. We could say that it's moving up. If the velocity is negative, the object is moving to the left. And if the velocity is 0, then the object is stopped. Okay? So this is what I want you to think about if we're looking at a position graph. Okay? This is going to be really important because we have a velocity graph as well. So this is position, so I know that the slope of position is velocity, or velocity is the derivative of position. Okay, so velocity is greater than 0, objects moving right, objects at rest, objects moving left, objects at rest, objects moving right, and it's at rest. Okay, that's what's happening here. So let's think about it. Let's see what's happening kind of if we were to look at this on a number line. So let's say that we have this number line, and here's where the object is. It starts out at 0. It's moving to the right, and it's going to move to the right until it gets over to x equals 2. Okay? So that happened in the first 2 seconds. Okay, then it sat there for a little bit. For a second, it sat there. Then it goes to the left. And it goes to the left from 2 all the way to negative 2. Okay, so it was here, and then it goes to here. Okay, so here it went to the right 2, then it went to the left 4 places. Okay, then it sat still again. So it's sitting here for a couple of seconds, and then it moved to the right and the right again. And I'm thinking this is about 1.5 right here. Okay, so it was back here at -2, and it came back over to about 1.5, so about right there. So it was here, came back to there. Okay, and then it sat there for 2 more seconds. So the things that you want to be able to tell from this graph is, well, how far did this thing actually travel? Well, if we want to know how far it traveled, we could say, well, it went 2 this way, 4 this way, and then 1.5 this way. So 6, 7.5. So 7.5 units if we don't care about left or right. So it went 7.5 units. Now displacement is different. Displacement says, well, where did it end up? Well, it started here and it ended over here, like at 1.5. So its displacement is 1.5. Okay. Another thing to note is, well, when did it change direction? Well, anytime the slope changes, okay, so it changed directions right in here. It was had originally gone to the right, it sat there, went to the left, sat there, went to the right, sat there. So it changed directions 3 different times. Okay, let me see if there's anything else. If I wanted to find the velocity at a certain time, I could just find the slope of that line. So if I wanted the velocity at 9 seconds right there, well, let's see, what's the slope of this line? So we go over 2, up 1.5. So 1.5, that's 3/2 over 2. So what's that? 3/2 times 1/2. It would be about 3/4 of a meter per second. Okay, so that's just the basics as a little introduction, and then we'll talk about all of this stuff right here later on. Okay, bye.